Hello. In this video we're going to be working through solutions to the problems that have been assigned out of section 3.1. So first we have here a linear function which is given. H of x is negative 3x plus 4. There are 4 parts to the problem. We're asked first to determine the slope and y-intercept of the function. So anytime we have a function of the form f of x, and in this case it's h of x, but our generic notation for functions is f of x, and that's what I'm going to refer to for a moment. If we have mx plus b, so things to point out here, the only variable to be plugged into the function is x, which is here, which means m and b should be fixed numbers. They are not varying. Okay, so this is linear. This is what a linear function looks like, and the slope is m, and the y-intercept is b. For this reason, this form of a line is called slope-intercept form. Now the y-intercept is obtained simply by letting x equal 0 and plugging it in. And observe, you would get m times 0 plus b, m times 0 is 0, and 0 plus b is b. So b is the y-intercept. The slope refers to if you did f of x plus 1 minus f of x. Notice x can be anything, okay? But I plug in 2 separate values, x plus 1 and x. Well, the first one is going to be m times x plus 1 plus b. There is f of x plus 1. I have simply substituted x plus 1 for x. And f of x is exactly mx plus b. If I distribute everything out, we get mx plus m plus b minus mx minus b. And observe, mx cancels minus mx, b cancels minus b, and we get exactly m. So f of x plus 1 minus f of x over 1, division by 1 doesn't change anything, this is just going to be m. So if you take any 2 points on the graph, separated x and x plus 1, so they are separated by a distance in the x-axis of 1, what we've seen is that the corresponding distance in the y-axis will always be exactly m. Okay. And this doesn't matter what 2 points you pick. So in this particular problem, the slope m is exactly minus 3, looking at the function up here, and the y-intercept is 4. Okay, then we are asked to use the slope and the y-intercept to graph the function. So the way we do that, the slope, as the picture I drew earlier suggests, indicates how far up the function goes every time you move to the right by 1 unit. So in this case, we are going to go down 3 units every time we move right 1 unit. And the intercept tells me exactly if I plug in x equals 0, which is the y-axis, we get out a height of b, which in this case is 4. So the line goes through the point 0, 4. If x is 0, then h of x is 4. And every time I move 1 unit to the right, I'm going to go down 3 units. So it's also going to contain, for example, the point 1, 1, because I have moved 1 unit to the right and 3 units down. And then I keep going in this general direction, both left and right. So here's a graph of our function. Okay. Part C, average rate of change of the function, simply for a linear function refers to its slope. So this is also negative 3. You can see this by saying if I take any 2 points, let's say x1, so I'm going to take 2 different values of x, I'll call them x1 and x2. What points on the line do they go through? Well, this point here is going to be x1, comma h of x1. This point down here would be x2, comma h of x2. And the average rate of change simply refers to what is the difference in the y-coordinates divided by the difference in the x-coordinates. Well, h of x2 is simply m times x2 plus b. Then h of x1 is m times x1 plus b. And I divide this by x2 minus x1. Observe that I have a b and a minus b. Those are going to cancel out. And leaving behind mx2 minus mx1 over x2 minus x1. I can factor an m out of the top, leaving behind x2 minus x1, which will now cancel the x2 minus x1 down in the denominator, leaving behind exactly m. So this is what average rate of change refers to. It says plug in different x values, get out different y values, and compute the change in y values over the change in x values. And for a line, it always works out to be exactly its slope. For part D, is this function increasing, decreasing, or constant? As we move to the right, the line goes down, so it is decreasing. Okay, on to the next problem. Very similar, we are given a line here. So the slope is exactly the number multiplying x, that's 1/5. The intercept is the number being added into after that, which is also what you will get if you substitute x equals 0, which is -4. Depending on how things are supposed to be entered into different systems, this might be entered as y equals -4, it may just be -4. Use the slope and y-intercept to graph the function. Well, I go through the point 0, -4. Now every time I move 1 unit to the right, I go up 1/5 of a unit. Okay, so if I go right 1, I'll only go up 1/5. So I'll have to actually go to the right 5 units in order to go up 1 unit. So the line looks something like this. The average rate of change is exactly the slope, that's 1/5. And since this line moves up as we go to the right, this is an increasing function. Okay, just as before, determine the slope and y-intercept. Now this one, it's slightly tricky because what number is multiplying x? Well, I could rewrite this as 0x plus 3. The slope is 0, and the intercept is 3, or y equals 3. So I go through the point 0, 3, because that's my intercept. And now if I move 1 unit to the right, I move up or down 0 units. The slope is 0, which means I stay at the same height. The average rate of change is the slope, which is 0. And since this is not going up, nor is it going down, this is a constant. It is the constant line y equals 3, or just g of x equals 3. All right, so now we have two linear functions. F of x is 5x minus 1, and g of x is negative 2x plus 6. We could do all the same stuff as the previous problem, find intercepts, slopes, etc. But we are asked to do something different. So for part A, we solve f of x equals 0. So f of x is 5x minus 1, and I want that to equal 0. Now we need to solve this for x, so I'm going to add 1 to both sides, giving 5x equals 1, and divide both sides by 5, giving x equals 1/5. There's the answer to part A. For B, we want to solve where is f of x bigger than 0. So where is 5x minus 1 bigger than 0? Nothing really changes here except at one stage. So I'm going to add 1 to both sides, giving 5x should be bigger than 1. Now I can divide by 5. Now I do need to be careful when dividing an inequality. If you multiply or divide an inequality by a negative number, you must reverse the direction of that inequality. However, we have divided by 5, which is positive. So I do not need to reverse the direction of inequality, and there we have it. Part C, solve f of x equals g of x. So that would be where is 5x minus 1 equal to negative 2x plus 6. I'm going to add 1 to both sides, and I'm going to add 2x to both sides. So on the left, I now have 7x, and on the right, I have 7. I divide by 7, and I get x equals 1. For part D, where is 5x minus 1 less than or equal to negative 2x plus 6? Well, I start off the same way, add 1 to both sides, add 2x to both sides. I don't need to worry about flipping inequalities when I add or subtract, so I end up with 7x less than or equal to 7. Now I'm going to divide, and I ask, did I divide or multiply by a negative number? I did not, so the inequality does not need to flip. X less than or equal to 1, and we have solved for x. Okay, finally, part E. We are supposed to graph something, so I'm going to erase some earlier work so that we have a bit more space to work with. Graph y equals f of x and y equals g of x, and find the point that represents the solution to f of x equals g of x, okay, which was part 3 to the problem, okay, which I have left up here. This was the solution to part C. Where is f of x equal to g of x? It should be at x equals 1. So let's see what that represents. So here are our axes, okay. F of x has an intercept of minus 1 and a slope of 5. So every time I move right 1 unit, I go up 5 units. So it's going up quite quickly. Okay, so here is f of x. G of x, on the other hand, has an intercept of positive 6 way up here, but a slope of negative 2. So every time I move right 1, it goes down by 2. Now, since I drew the red line f of x to have a slope of 5, a slope of negative 2 is not going to be quite as steep as that. So here's g of x. Now this point right here is the point of intersection, and it happens at x equals 1. And observe, if I put 1 into g of x, I get negative 2 times 1 plus 6, or negative 2 plus 6, aka 4. However, if I was to plug 1 into f, we would compute f of 1 equals 5 times 1 minus 1, or 5 minus 1, or 4. So the point 1, 4 belongs both to the red line, plug in 1 to f of x and get out 4, but it also belongs to the blue line, plug in 1 for x and get out 4 for g of x. So this point belongs on both lines. It's exactly where the lines intersect. All right, referring to the following figure, okay, solve f of x equals 30. So I want to get out a y value of 30, and that happens right here. So x equals 20. For part B, where is y equal to 48? That happens right here, corresponding to x equals 44. For the third, we want where is y equal to 0? That's this point here, corresponding to x equals minus 20. So these x values are our solutions, by the way. Now I want to know, where is f of x bigger than 30? Where is the y value bigger than 30? Now this is the line for y equals 30. Notice I have drawn this line to go through this point because that is a point that is already labeled as having a y coordinate of 30. So now what I want to know is what x values produce y values larger than 30. Now looking at the line, here is a y value of 30. How do I get values of y bigger than 30? I must move to the right. So x equals 20 gives me a height of exactly 30. To get out a height larger than 30, I must move to the right. In other words, I must plug in x's larger than 20. Similarly, how do I get how do I get out y values less than or equal to 48? Now here is a point that goes through y equals 48, corresponding to x equals 44. So how do I get out y values less than or equal to 48? I must be to the left. Now this point here was x equals 44, and to the left of 44 is x is less than or equal to 44. And finally, for which x values will the y value be strictly in between 0 and 48? Well, x equals negative 20 gives me a value of 0. X equals 44 gives me a value of 48. So how do I end up with y values in between? I take x values strictly in between negative 20 and 44. Okay. Now we are given a function c of x, which models the cost of towing a car, where x is the number of miles to be towed. So for part A, we are asked, what is the cost of towing a car 50 miles? So that just means x is 50. So c of 50 will be the cost is 1.5 times 50 plus 95. 1.5 times 50 is 75. And 75 plus 95 is 170. So to tow a car 50 miles will cost $170. So in part B, the cost is given at 185. That means c of x is 185. The cost is already known. But c of x should be 1.5 times x, 1.5 times x plus 95. So if I subtract 95 from both sides, we get 90 is equal to 1.5 times x. I divide by 1.5. And we get x equals 60. In part C, suppose you have $149. What is the maximum number of miles that can be towed? So since I only have $149, I need the cost to be less than or equal to $149. I can't tow more than that, I won't have enough money. But the cost should be 1.5x plus 95. So 1.5x plus 95 must be less than or equal to 149. And now we proceed as we've done before, subtract 95 from both sides, leaving behind a 1.5x is less than or equal to 54. Okay. Now I can divide both sides by 1.5. Whenever I divide an inequality, I do want to be a little bit careful. Did I divide by a negative number? I did not. Therefore, I do not need to reverse the inequality, and we get x is less than or equal to 36. Okay. And finally, in our last problem, we're given two functions, r of x and c of x, r standing for revenue, c standing for cost. In both functions, x represents the number of units produced and sold each day. And we're first asked, find the break-even point. Where does revenue equal cost? So where is revenue going to equal cost? Well, revenue is 20x and cost is 12.5x plus 37,500. We need to solve for x. Find x. So I subtract 12.5x from both sides. These cancel here. Here I end up with 7.5x equals 37,500. We have to divide by 7.5. For x equals 37,500 divided by 7.5. Pulling out a calculator quickly to check this, we just end up with a result of 5,000 exactly. So if I can produce and sell 5,000 units, my revenue and cost will be exactly equal. Part B is very similar. We are asked to find where is revenue going to be bigger than cost. Okay, how many units do I have to sell in order to make money, in order to take in more revenue than I spent as a cost? Very little changes here. Okay, the revenue is still 20x, the cost is still 12.5x plus 37,500. If I subtract 12.5x from both sides, I have 7.5x needs to be bigger than 37,500. I can divide by 7.5. Every time I divide an inequality, I am careful to ask, did I divide by a negative number? I didn't, so I do not need to flip the inequality, and we simply get x larger than 5,000. If 5,000 units represents the break-even point, it stands to reason that more than 5,000 units represents a profit. Okay, so that's it for section 3.1.